This video will be an intro to turning on the HAAS CNC lathes. Working on the CNC lathes, we're going to be using the coordinate system where the center line of the lathe spindle will always be X0 and the Z0 will float or reset to the face of the part depending on the part dimensions. Absolute programming will occur when all points are in the XZ coordinates. Incrementing programming, the distance from point to point, will be when your points are with UW, where the U is the x-axis and W is the z-axis. Just like programming on the milling machines, G and M codes will communicate your programming needs. Our HAAS lathes in the lab have machine defaults, and this is an automatic function of the machine. The HAAS lathes will automatically default to the following codes on this page. A list of common G and M codes can be found in our text on pages 18 through 23. Our programming structure for the lathe will be very similar to the mill. We will begin and end with a percent symbol, just as we did on the mill. Our next line will be G20, G18, G99. This will implement that we're in inches, the XZ circular plane, and feet per revolution. Next, we will do a rapid code with T101. This will call up tool 1 with an offset of 1. If the tool was 12, we would call up T1212. Then, we will do a G50 S1000. G50 is a spindle max RPM limit. This spindle speed can be anywhere from 1,000 to 5,000 depending on the machine that you're on. After that line, we'll do G97, S200, M3. G97 will cancel constant surface speed, M3 will turn the spindle forward, and the RPM will be a straight RPM of 200. When I say straight RPM, I mean that there's no constant surface speed. The spindle is just rotating at 200 RPM. The final line of the beginning of our programming will be G54. We may not be using G54 at our machine setup, but we'll go over the different ways to set up your tool length offsets. The first method for setting up our tool length offsets is going to be using a probe. This probe can be used on turning centers, not on tool room lathes. A probe will come down with a known probing position, which you can set your tools up to. Your tools will all be having an X and Z offset, and then you would set a G54 Z offset. Your G54 would have a Z location, and then all the rest of your tools would fall into line with that location that you set for G54. This next method is similar to using a probe, but without the probe. You could set up your X and your Z to a known diameter and a known face, such as using the chuck. Then, with an established tool, you could set a G54 X and Z per the size of the workpiece. By doing this, all the other established tools will fall into line with the dimensions of the stock. This is very convenient if you're doing 1 or 2 workpieces at a time, because then you can change your diameter and your Z's quickly with your G54s. This last method will require no information in G54. You will set each tool to the diameter and the Z location of the workpiece that you're working with. This would require you possibly taking a cut off of rough stock, making a measurement, and then entering a diameter and your Z and your X diameter measure. This will be good for projects in the lab because it gets you practice of touching off tools and making cuts, but in a production setting it is not ideal. We're going to continue our programming as if we were programming the OD of this workpiece. We won't be doing any parting or any ID work, just facing an OD rough and OD finish. After we set up our tools, we will move to a X 5.0, Z 1.0, a safe location. We could move closer to the diameter, but X 5.0 gets us away from our stock, which is 2 inches. I put an option stop in after this movement so we can double check our locations are in the correct spot. After that, we will have to turn the spindle back on with a G96 S400 M3. This is constant surface speed of 400 and spindle on forward. We'll be doing a facing op from here. A line movement with a feed rate of 10 thou per rev down to a Z negative 10 thou, and then moving X negative 0.75 at a feed rate of 0.006 thou per rev. This is a nice finished feed rate, and we're moving to a negative X number to take away the tool nose radius. And then we'll do a safe movement off the part to Z.1 and then rapid back to X.1. You could go to X 5.0, but this line here, X 2.1 and the Z.1 will be our stock definition for our roughing cycle. It's very important that we have this line of our stock definition before our roughing cycle, because this will define our stock to let our roughing cycle know the parameters in which to cut. This next paperwork will show some information on roughing cycle using G71. We'll have to collect our points off of our prints, and we'll have to include some parameters for cutting, but G71 is a great roughing cycle for removing material. So let's gather our points from this turned part print and start applying them to the program. So following our stock definition, I have an M01 to confirm that I'm in the right location. I have to turn the spindle back on with a G96 S400 M3, and I get into the roughing the OD cycle. Use G71 with a bunch of codes after it. This slide here will break down what each code represents, and if you notice that my X and my Z locations are the point-to-point profile of the part to be made. This PDF gives good information on a G70, which is going to be a finishing cycle. You can find this in our HAAS textbooks. And from here, we're going to call up tool 2, which is a different insert, set up the beginning of our code, then move to a G70 cycle to cut our finished profile. To conclude this video, I'll be going through facing and roughing this part using Discriminator, our CNC edit software. Discriminator will help us see the geometry, but it won't show any can cycles. Also, it won't show many errors. You'll have to hook up to a simulator or hop on a machine down in the lab to see if there's any problems with the program.